This is what Tattooine's most iconic scene from Star Wars looks like. A double sunset. But is this even possible? Can such a two-star system like this even exist? And if so, how would that even work? And if that is possible, are the other space oddities from Star Wars possible? Like the Salt Planet from Episode 8, or the Eye of Aldhani from Andor? Well, I guess it's time to see if Star Wars actually knows about the stars. Well, we first see Tattooine's dual suns in A New Hope, right as Luke leaves for his grand adventure. Well, technically we see it canonically first in Episode 3, but in real life we see it chronologically in 4. Star Wars timelines, man. Annoyance with the Yoda-like order the movies came out aside, we can see that Tattooine orbits around 2 stars. We know that Tattooine orbits around both of them at the same time because both stars are setting at around the same time, meaning they're closer in proximity to each other relative to Tattooine. So, is a 2-star system possible? Well, we do have a term called binary stars in astronomy, which, as you might guess, refers to things that relate to 2 stars. However, binary stars can actually refer to a lot of things, some of which not at all helpful to our situation. For example, stars that are so close together from Earth's perspective that they look like one star can be called double stars, a type of binary star. However, in reality, these double stars could be super far apart. Fun fact, a decent amount of stars in the night sky are double stars, like Mizar, a part of the Big Dipper. You can't see it with the human eye, but it's actually 2 stars really close together. And by super close together, I mean not at all close together. Anyways, what we're actually looking for is something called circumbinary stars, stars that revolve around each other. Sometimes the stars can be semi-equal in size, and sometimes one is just much smaller and essentially just orbits the other. But because it's almost impossible for them to be the exact same size, one is going to be larger. And in a circumbinary system, that star is called the primary star. Based on the fact that we have a name for it, as you can probably guess again, circumbinary star systems do exist. Great, a 2-star system can exist. But can there be 2 stars and a planet orbiting around both of them in a stable orbit? Again, absolutely. Not only can it, but we found some planets that orbit 2 stars. Even crazier than that, we found one planet called Kepler-47d. I know, it's a bad name, scientists name it, which not only orbits around 2 stars, but also has a stable orbit in the habitable zone in that solar system, meaning it could potentially have life on it. It's quite a bit larger than Earth, so the conditions might be a bit whack, but life should still be possible as far as we know. So yeah, not only can a livable planet orbit 2 stars like Tattooine, but it might actually exist. Wow, that was easier than I expected it to be. Moving on. Objection! Just because a planet can orbit around 2 stars doesn't mean that a planet can orbit around these 2 stars in particular. Taking a quote from Wikipedia here, there is a wide range of stellar configurations for which circumbinary planets can exist. Primary star masses range from 0.69 to 1.53 solar masses. Star mass ratios from 1.03 to 3.76. We've only seen circumbinary star systems exist within certain parameters. There's a possibility that a binary star system outside of these parameters could exist, and that we just haven't seen it yet, but we've seen a lot of binary star systems, so I'm going to assume that these are general limits. Once you find one outside of these, just to prove me wrong, let me know in the comments. Well, this begs the question, do the Tattooine stars fit into these parameters? Well, we're never given the exact sizes of these stars, which I'm shocked by. I thought Star Wars was for nerds. Nah, I guess that's what Star Trek is for. But surprisingly, we actually don't really need it, because we can use what we're already given in the movies. We can't use their visual size, because it could vary depending on which star is closer to Tattooine at the time. Same reason you can't compare the sun and the moon by just kind of looking at them. But instead, we can use their colors. We see the stars a total of 3 times throughout the live-action movies. It probably appears more in other things, but I'm not going through the TV shows and all that. Sorry. It appears in the 3rd movie, the 4th, and the 9th. I know, bad movie, but just stick with me here. Unfortunately, the colors do seem to vary quite a bit, which actually isn't crazy unrealistic. Photos taken of our sun can vary quite a bit depending on things like camera quality and saturation. It does make it harder for me, though. For now, I'm going to say that this one is yellow and that this one is orange. Which, now what? That didn't seem to help. Well, using their colors, we can actually get their size. We can do this using a Hertzsprung-Russell diagram. Yeah, they hyphenated their names for the graph to make it harder. If you have an issue with that, take it up with them. This graph relates color to temperature and size, which are all correlated. You see, the larger a star gets, the more hydrogen and gravity it has, which means the more fusion it does. The more fusion it does, the hotter it is, and the more energy it makes. The more energy it makes, the more energy the light it gives off will have. More energy means higher frequency, which means a different color. You get all that? Well, the Hertzsprung-Russell diagram uses this fact to sort the stars into different colors, which each have their own unique size and amount of energy. We can use these classifications given by the graph to find general sizes for our mystery stars. For reasons that will become obvious, I'm going to start with this yellow star. Because it's a yellowish star, my guess is that it's in fact a G-type star, like our sun. G-types generally have a mass of around 1.1 solar masses, which makes sense. Our sun is a G-type, so the average for G-types should be around the mass of our sun. Now moving on to our other star here, I'm going to assume the worst possibility, that they're as far apart as possible, and that it's in fact an M-type red star, which in general has a mass of around 0.4 solar masses. This makes our yellow star clearly our primary star, which we could have guessed based on the fact that yellow is a higher energy frequency than red. Using the yellow star as our primary star, 1.1 solar masses cleanly fits within 0.69 to 1.53, so that's good. On top of that, 1.1 divided by 0.4 is 2.75 as our worst case solar mass ratio, which also cleanly fits within the parameters. So yeah, a binary system like this could totally exist. Objection! Hold up. I showed the Hertzsprung-Russell diagram earlier, but I neglected to mention these stars up here. These are called red giants, stars that are massive but are near the end of their life, that are emitting less energy as a result. So even though they're large, they're still red. Our red star could be one of these stars, which would make it the primary star and would ruin the solar mass ratio. Objection! Nope, I'm fairly certain that this star isn't a red giant. I think that because, as I mentioned earlier, red giants are stars near the ends of their lives. It's also important to note that circumbinary stars almost always come from the same nebula, meaning that these two stars formed at roughly the same time, and this yellow star still appears to be young, meaning an old red giant probably couldn't have formed yet. While the lifespan of stars does vary, it varies mostly because it depends on the size of the star. In order for this star to be dying so much earlier, it must have been magnitudes larger, and the binary system wouldn't have formed anyways, as a star that massive would have just eaten the other one a long time ago. This means that this star is in fact not a red giant, and thus our original assertion is still correct. In conclusion, yep, this Tattooine sunset could totally exist. Now on to Crait, the salt planet from episode 8. I know, I'm sorry to bring it up again after all the Star Wars fans spent years trying to forget about that movie. However, scientific progress never stops. Well, it turns out that it is indeed covered in salt. That's why this bunker thing in the movie actually exists, because the planet was used by the Empire as a mining operation for its salt and minerals. What's interesting about this salt is that salt crystals like these almost always form from water, at least on Earth. However, if you noticed, there's more than just salt here. Underneath the white salt is this red rock. Well, it turns out that this isn't salt, but actually it's a mineral called, oh my goodness, rhodochrosite. How do I know that? Well, that's because that's what it says on the wiki, and I trust that. However, I was kind of worried that the search for the truth would end there, but it turns out that rhodochrose, never mind, I'm just going to call it that stuff is a very real mineral. In real life, it's also called manganese carbonate. To form manganese carbonate, it requires igneous and metamorphic processes. This means it needs lava, heat, and pressure. Thus, in total, we have our list of requirements to test if Crait can exist. 1. Can a nebula, and therefore the planets that formed from it, contain large enough amounts of sodium, chlorine, manganese, and carbon to form such a planet? 2. Does this planet have water in order to form the salt that covers this planet? 3. Does this planet have the volcanoes and pressure necessary to form that stuff? To start, can a nebula possess vast amounts of these elements? Totally. Nebulas can have all sorts of elements, especially if a supernova occurred in proximity. Is it likely that a nebula would have so many of these dense elements? Absolutely not. But the Empire picked this planet specifically for mining because of its minerals, meaning even Star Wars agrees that this planet is a 1 in a million thing. Next, does this planet have water? Well, it does. It's contained in these subterranean tunnels and oceans. I know this because that's what the wiki says, and again, in the wiki we trust. That was easy, and no, it's totally okay for the water to be hidden under the surface. That's actually partly how the salt flats on Earth formed. Water can form salt and then kind of push it up to form similar looking things. Or it could have just formed this layer of salt and then evaporated. Either way, it works out. Finally, can it form that stuff? Well, I didn't find a mention of volcanoes on the wiki. Gosh dang it, making my job harder. However, look at this bunker again. Notice something? Yeah, it's built into a mountain. And what do mountains mean? Yeah, it almost certainly means tectonic activity, which then implies everything we need to form manganese carbonate: lava, heat, and pressure. So, in total, Crait meets all the criteria we were looking for. Planets can form with these elements, Crait does have water, and Crait does almost certainly exert igneous and metamorphic processes. So yeah, Crait could exist in real life. Now, prettiest for last, the Eye of Aldhani. I actually watched Andor for this, and you guys were right. It was very good. The eye, put simply, is a meteor shower. The show tried to give some sciencey sounding explanation, but it was just science mumbo jumbo, so I'm just gonna ignore it. The visual effects are very pretty, with all sorts of greens and blues, with one character describing it as 50 meteor showers all at once. Now, could it exist? Well, while doing research, I came across an article asking the same question. I clicked on it because I thought all of the work was done for me and that I could take inspiration from this article. You can read it if you'd like, but here's a quick summary of what it says. It says that the eye isn't really a meteor shower and proposes that it's instead a migration of spacefaring organisms. It states this for 3 reasons. 1. The eye doesn't occur every year when in real life meteor showers occur annually. 2. The exact timing of when it occurs is predictable down to the minute, which is impossible on Earth. 3. The eye should be visible from anywhere, but in the show, the locals view it from a very specific valley. However, I might be getting ahead of myself here, but I actually do think it is a meteor shower. I'll admit I'm a bit more unsure of this one, and I'd feel dishonest if I didn't admit that, but this is what I think. As for the first point, it is true that meteor showers occur every year. However, it's also true that some meteor showers are way more intense on certain years. For example, the Leonids meteor shower is much more vibrant every 33rd year. To explain this, let's dig into the cause of meteor showers. Meteor showers actually come from comets, which makes it kind of a confusing name, but whatever. What happens is that while soaring through space, these comets actually leave a trail of ice and rocks. That's why they look like shooting stars, because of this trail. And when we intersect with this trail on our yearly orbit, the rocks left behind by the trail fall into our atmosphere, causing a meteor shower. This explains why they occur every year. It takes a year for us to orbit back into the comet's trail again. However, some comets take longer than a year to return, meaning that every time you intersect with a trail, there will be fewer meteors since the last time since they haven't been replenished. This is why some meteor showers are stronger in certain years, because that's how long it takes for the comet to come around and add more meteors. So this could be a reason for why the eye happens every 3 years, that it does happen annually, it's just not nearly as spectacular. This does work, although I don't love this explanation, honestly. And I actually think there's a way cleaner answer. Yes, they said it happens every 3 years. However, that really only doesn't make sense from a strictly Earth perspective. They could have been using year as a unit of time. It could have been coruscant years. Aldhani could just take 3 coruscant years to make one orbit. Thus it occurs every 3 years, but only once per orbit. In my opinion, this makes even more sense. The people describing the eye are talking to Andor, who's just arrived on the planet. It wouldn't really make sense to use Aldhani years with a man who probably barely knows how long that is. He probably used a unit of time that Andor could intuitively understand. This same detachment from an Earth-centered perspective works for the second point as well. Yes, we can't predict it down to the minute, but in Star Wars, some computers can plot hyperspace routes and thus must know about pretty much every rock in the galaxy. So it makes sense that they can predict it this accurately. As for the last point, that a meteor shower like the eye should be visible from the whole planet, I actually think it is. While they do speak of the native peoples migrating to a specific valley in order to see it, they also refer to this valley as having cultural significance. So my guess is that this valley is just one of the best places to see it, and that it's important because of its cultural relevance. I don't actually think it's the only place to see it though. Going through all of these points, I believe that nothing really proves that it's anything but a very impressive meteor shower, and nothing proves that it would be impossible either. If you were wondering, these bright colors can actually happen if the meteors contain lots of sodium and magnesium. In conclusion, yeah, all of these things that I listed are in fact totally possible, so maybe Star Wars is less sci-fi and more sci. Except for the magic space wizards, that's still dumb. I went into this with an open mind, fully expecting at least one of these to be impossible, but that wasn't the case. They ended up being interesting and valid concepts. Except for the maelstrom from Solo, I looked into it, but it ended up being so ridiculously fake that it wouldn't have even been fun to talk about. Literally nothing in real life is like that. They just made it up to make the Kessel Run make sense, but everyone knows that that was just them throwing in science-sounding words into the movie, because as everyone knows again, parsec is a unit of space, but Solo tried to use it as a measurement of time, which is dumb and silly and dumb. This was Baldr, your online friend. I feel it important to reiterate here that I'm no astronomer, so if I got something wrong, let me know, and don't trust anything I say at face value. I'm kinda dumb. I encourage all of you to look into anything I said if it looks interesting, or if it feels like I'm totally wrong, which I could be. Also, if you stuck around this long, I can finally unload some hot takes. First of all, Andor was very good. Second, I rewatched Solo, and it's actually a pretty decent movie. Third, the 8th movie, no, I'm not going to defend it, but the Salt Planet was very cool visually. Anyways, I'm going to go jump into a gravity well. I hope I don't get spaghettified.